But we've got a lot to cover. We need to start. Any volunteers to offer a prayer for us this morning? Anyone? Anyone? Thank you, Caroline.
Our Father in heaven, we are so grateful to be able to gather in person under the circumstances, and we're so grateful for our professor and the work that he puts into teaching us, and ask that our minds might be opened and that we can have inspiration to understand what we need to hear from the Savior Jesus Christ.
Amen. Thank you so much. Okay. Quick announcement, something I forgot to talk about last time. Usually on the web assign, you will report that you watched the video and that you read this section. We're not starting that till like 1.3. So some of you I know were looking for those questions. We don't have them on there yet. So just FYI. Any questions about devotional or comments about devotional? We'll take one or two. Yes. Yeah, very nice. Okay, summarize for those that are online because they can't hear you. She talked about really like the idea that unity, you can be unified and still have diversity, right? And have those things. That's a poor summary, but should have brought my thing back there. How about one more comment? Michelle.
I had never heard the story of the hiding spot or hiding place before, and so I just thought that was so fascinating, and that was just such a cool story.
It is a cool story. She was in my office. We were listening to it together. So. Okay. Any questions about 1.1 or 1.2? Yes, Philip.
There's this one question on the homework there was talking about, it's kind of like after class last time when we talked about that one graph that was shown where it said, you said in your notes, you don't really understand that, because we use that a lot.
Oh, right.
And then I was kind of it was applying problems to that, and I struggled to do whatever. It was like the question 14.
Oh, with the hexagon?
Yes.
Okay, so I had a regular hexagon centered at the origin, and it said, think about these two vectors. I forgot, I have big markers. There we go. That's better. 0A, and think about vector B as 0B. And then it gave you some other vectors. I think you only had to do one. And write it in terms of A or B. Is this the one, Philip? Okay. So it said, how do you write the vector AB in terms of big A, capital B in terms of little a, little b? Well, this is A, this is B. Where is this vector? Yeah, Roxy goes like this. Yeah, so which direction does it point? Yeah, so it starts at A, goes to B. Okay, so that's AB. So how can we represent this vector in terms of these? Anyone got an idea? Caroline? Is it A plus B? So here's A, here's B. So when we add vectors, if we take A, we'll end up here, and then we add B to it, we'll end up to there. It's not the dot product. It's not the Pythagorean theorem, but there is a strong connection there. I drew this as 90 degrees. This is actually only 60 degrees, so can't quite use that. B minus A. So if the addition doesn't work, what about subtraction? So subtraction is what we can use to get a vector that's between the heads of two other vectors, okay? So if this was A and this was B, then you have A minus B or B minus A, and I always remember you subtract the tail. So this would be B minus, this one that I drew is actually B minus A, and the one going this way would be A minus B. And one way to think about that is if this is A minus B, because if I take B and add A minus B, I better get A. See that? And if I actually do the addition like we did here, if I follow B and I follow A minus B, I end up with A. It's connecting end to end. So does that help, Philip?
Yeah, okay, I misunderstood Tom, because I was trying to do, the book it gets kind of confusing where it says, it was kind of on a grid, and so it said, it with reference to origin, this vector is this, but with reference to other vectors, this vector.
Oh,
I think
gotcha.
that's more complicated.
Okay. All right. Thanks for bringing that up. Yes, Caroline.
Can you do the how to do the projection from like the cosine theta equation, like how to derive the equation for the projection?
I'm going to send out a video about how to derive the dot product and how the cosine thing. Yeah, I'm going to send out a video on how to derive that. The book does have it. I don't like the way the book does it. Mine's similar to the book, but I expound it a little bit more. So great question. So that question for those online asked me to derive the connection between the cosine of theta and the dot product of two vectors. Okay. Let's move on. If you have more questions, pull up Zoom and chat with Michelle, and she'll answer them for you. So with your neighbor, so a lot of you filled out, well, actually not very many in this class, but I sent out a survey, a preference survey. Some of you answered it, only about 12 or so, at least by the time I pulled it off. But here's 4 students. I can't remember which class they're from. The question is, who is the best match for student A? If we're going to match up people on like preferences, it might be a good study partner. Who would it be? So yeah, this isn't using any advanced math. This is a 6th grade math question. I could give this to 6th grade students and they could reason about this. So with your neighbor, reason through who would be the best match for A and think about why. Like why would you argue that that person's the best or the worst match? So go ahead, take a few minutes and do that. Yeah. Yeah, just quick clarification, I should have specified. So it was a 5-point scale, those of you that took the survey. So a -2, they really like, it goes from -2 to 2. So -2, -1, 0, and 1 and 2. And I gave 2 options. I can't remember all of them. Night owl versus morning glory, beach or mountain, camping versus resort. I can't remember all of them, but what was it? Okay, so anyway, you're one end or the other, and like a 1 would mean you're a little closer to this one, but not all the way. So 0 means you didn't matter. Okay, so go ahead, back at it. Okay. I know that wasn't tons of time. We'll just take a quick survey. If you think, we'll say student B is number 1, student C is number 2, student D is 3. So just hold your fingers up if you think, 1, 2, or 3. If you think B is the best, C is the best, or D is the best match. So go ahead, hold them up. 1, 2, 3. I don't see any 1s. I see lots of 2s and 3s. Okay, great. Some of the things I heard, I anticipated hearing, and it was pretty close. Like just the way you guys went about doing this. First, you lined up things. You were looking at each question, right? How they answered each question. So you paired them up. Same sign meant they were a better match. Different signs meant they were a bad match, right? Kind of obvious. More same sign pairs meant you were more similar or better. And more different pairs means less similar or worse match. This went along well, what you guys are thinking? Okay. I heard some people working with kind of some averages and other stuff, but this is some of the stuff that I heard. We're going to go something a little more nuanced now. Still same idea, trying to figure out like what would be a good match or not. If we look at the red, which of these questions, if you just look at those 2 red pairs, so we're comparing student C and student D right now, which of those red pairs would carry the most weight to you? Are they the same? Which would say like that they both have the same sign. I mean, you'd have the 0 there, but which of those is going to carry the most weight? And same thing with the green. We have a -2 and a 2, -1 and a 1. They're both different signs, both the same distance. They're each 1 from 0 or 2 from 0. Should we weight those the same? Philip.
Are we mainly using relation to each other?
Yeah, good question. Right now, just to each other. So maybe one way to think about it is if you did have 2 people that were one person was all -1s and one person was all 1s, or you had another pair where one person was all -2 and the other person was all 2s. Would you say that they're the same, different? So a lot of people are shaking their heads. So someone would say, like, why are you shaking your head? Those of you did. Spencer? Okay. Here, I'm going to keep getting to this.
So if you take the 2 green ones, I kind of see it as the way we had the 5-point scale. There's the extremes where it's like almost solely interest in that one thing and none on the other. Whereas the ones on each side have a little bit of interest. So when you have the -2 and the 2, that's somebody over here who has no interest in the other side, and the other person has no interest in this side. Whereas in the -1, they both have a little bit of interest in the other side. So that difference is a little less dramatic than those that are just extremely on both sides.
Okay. All right. Do others agree? Okay. See a lot of head nods. Anyone have a different idea about that? Okay. How do we make sense of the 0? How about the 0 and the 1? I forgot your name. Eddie? I remembered your name.
Well, for me, I'm just kind of thinking about it on a 5-point scale rather than with negative numbers. So I'm kind of thinking about it like, I imagine the 1 to 0 is more important because it's like a ratio of 3 to 4 rather than a ratio of 4 to 5.
Okay. All right. So if you think of the scale differently, you're like, maybe it's a bigger jump from 0 to 1. It's like an infinite jump, right? Then 1 to 2 isn't as much. So Eddie's giving an argument on like we should actually weight 0 to 1 more than the other one. Cameron. We ran today. This is like making an exercise.
So I think what's most important in determining whether 2 students are similar or not is the difference between the scores. Like 0 to 1 is a movement of 1, but they're still pretty close. Whereas the -2 to a 2 is a much larger difference. So I think if we were to take the differences of each individual score and maybe add them together, the closer ones would be a lesser value.
Okay. So would you say like the 0 to 1 and the 1 to 2, we just consider the same?
Yeah.
Okay, so Cameron gives an argument for the same. So Cambria is shaking her head. Okay, so we have, Eddie gives an argument, the 0 and 1 should be, Cameron gives an argument that they should be the same. Cambria, what do you think?
I think if it's coming from 0 to 1, 0 means you're completely neutral about it. At least for the 1 to 2, they both like or dislike the same thing. If you're neutral about it, I feel like it kind of could go either way. So I guess, I mean, I guess if you're neutral, then you wouldn't really care if someone liked something or didn't like it either, though. But you're more similar if you both like it or dislike it, I think.
Okay, so you're giving the argument that 1 and 2 should be weighted more than a 1, 0. Right, because you said like, hey, they both like it some, right? And that's, it says something stronger than, hey, someone that doesn't care much and someone that likes it. Okay. Great job. Let's hear it for those guys. Everyone let's give a hand for everyone that contributed so far. Okay. Thank you. Okay. I kind of go along with Cambria on this, although you can certainly do it differently, especially depending on the context. Okay, this context I kind of agree with Cambria. So at least if we agree with Cambria, we get a couple more things that we could add to our list. A pair with a 0 in one cell doesn't carry much weight compared to other pairs without any zeros. That's the way I'd summarize kind of Cambria's argument. Like you really don't care, so it kind of doesn't matter as much what the other one is because it's just kind of ambivalent. And 2, 2, pairs of 2, 2, a -2, -2, or 2 and a -2 means that means something more. It's like a stronger association or disassociation than 1, 1, -1, -1, or 1, -1. Okay? Are we recording this? Did you hit record? Thanks. Okay, so these things together actually suggest a certain calculation we can do. One, we line up pairs. All of you were kind of looking question by question. So you pair up corresponding values. This, we can use multiplication to capture these 3 aspects. So if you multiply 2 things with the same sign, you get something positive, whether it's positive, positive, or negative, negative. If you multiply something with different signs, you get something negative. If you multiply something with 0 or just a really small value, it becomes 0 or a smaller value, so it doesn't carry much weight. And multiplication with like all 2s, no matter what the signs are, is going to be larger values than all 1s. Okay, so multiplying the pairs actually captures our feelings that we had, at least if we agree with Cambria. So, and then finally, you guys were talking about like how many, if you had more same sign pairs versus fewer same sign pairs, you're trying to add up or compare that, right? Well, here, if you just sum up those products, sum up across all of those pairs, then I might get us something. So our intuitive idea about trying to figure out who's similar and who's dissimilar suggests this kind of match calculation to comparing student A and B. We look at pairs, we multiply them, and we add them all up, and we get some total. Okay? Question so far? Now, I know you guys know this is the dot product, okay? So, but the book doesn't do a great job, and I don't know if I did a great job. I didn't do a great job in the peanut butter book about motivating like where this would come from. So, but this, when you just naturally start to compare like which vectors or which values are more like each other, this is the kind of thing that you naturally do. It captures the kind of reasoning. Yeah. Yes, Philip.
What you were just talking about this being the dot product, just kind of trying to apply that. Like kind of the three important values in a dot product we see in something like this is like 1, -1, or 0. So are you saying if we did the dot product and we got 1 as the answer, that means that they're pretty much the exact same? Perfect.
We're actually going to get to this. So you're jumping ahead. So, but yeah, good thinking. Yeah. So for A and B, we get a -20 when we actually do this dot product. Okay. Yeah, the values Philip was raising, we'll get to those. How would you make this large? What would you do if you could pick some values to make this calculation large? I should say large and positive. What would you want? Yes. Both put 2 for everything. So large values. What about the signs of those values? Yeah, okay. All right, so same signs. So as long as you got the same signs and large values. So very nice. What about, what if you wanted it to be close to 0? Yes, in the back. Someone's mostly neutral. So one strategy is put all neutral. So 0, 0, 0, 0, 0, then this is going to produce 0. Okay, so that's one strategy to get a 0. Very nice. There's another strategy. Isaiah. Okay, very nice. So kind of you'd have lots of positives, lots of negatives after you did the products, and they'd add to 0. Okay, and to make a large negative sum, you would want them all different signs. Okay, so they all kind of have opposite preferences on each of the questions. Okay, and so those large positive values means they agreed a lot. The large negative values means they didn't agree a lot, and the small values means they agreed on some and they didn't agree on others. So this is our dot products for each of these. I did do the dot product with student A with itself. Okay, so you might think of like that's like the perfect match score for student A is 30. Did this match what your ranking was? So some people thought at least the best one was C or D. No one picked B. I should have asked about which one was the worst one. So, but if you guys all picked C or D as the best, then I imagine a lot of you had B as the worst. So, but yeah, it was kind of hard to tell with C and D. There were reasons why you could go one way or the other way. So we already talked about this. Large positive means they're somewhat similar. Large negative means they're dissimilar. Small values means they're kind of unrelated. This a score of 30 here for A, means like would be a perfect match. What would a perfect match be for student C? Philip? It's not 2. Okay. Yeah, but were you adding up all?
Oh, because 2 is the dot product. Oh, I see. Yeah, it would be.
So Philip said scored a 10. So I heard some other people. 14. Okay, I see people doing 14. So you don't have to do a square root yet, but because the dot product, you just square each of these numbers and multiply them by itself and then add it up and get 14. I think you quickly summed to 10 instead of 14, but yeah. The dot product, if you take the dot product with itself and then take the square root, you do get the length of the vector. So 14. Okay, so my question is, why do you get a perfect match with a perfect match for student A, you need 30. A perfect match for student C, you need 14. Does that bother you a little bit? Caroline.
I think the closer it is to 0, the more like neutral the student is on most things.
Okay. So, so what does that mean if student C needs 14 for a perfect match?
Someone who's just as neutral. I don't know.
Okay. So they don't have as strong feelings. So they don't have as many 2s. They can't get as large. So, okay, nice. Okay, others? Eddie?
There's multiple perfect matches for student C too.
Why would you say multiple student? Why multiple?
Because you could still change out the numbers that you're dotting it with, and it would still give 14.
Ah. So we could dot student C's vector with other vectors and get 14, and some of them would be quite different and
Yeah.
might not be the perfect match. Okay, tricky. So here's something else to talk to your neighbor about. Okay, try to help us get into what's going on with these dot products. We've got a vector A, and I've got 6 other vectors. Which vector would you say, which vector is most similar? Which vector is the second most similar? And which vector is the least similar and the second least similar? Okay, so there's a question. So talk to your neighbor, talk about why you would say they're similar, why you would say they're dissimilar. Okay.
B and A are the closest together, but E and A are yeah, so if you want to, if we just compare.
Okay. Take 30 more seconds. Okay. So to report out, we're going to just do a little sign language, okay? So you're going to tell me which one you think is the most, and you're just going to do V, E, C, T, O, or R, okay? All right, so which one's the most? Go ahead and raise your hand, do the language for which one you think is the most. So, okay. All right. Okay, how about the second most? Put your second most up there. Okay. I saw lots of E's for the first. I see lots of V's for the second. Did anyone do any R's for the first or second? Yeah. Why did you do an R? Okay, he said if you project R onto A, it's really close in magnitude. And actually, it is exactly that. Okay, so why did people pick, someone did pick T. So back there, someone picked T. Why did you say T? They lie on the same line? Don't doubt yourself, come on. You're a trend breaker. Okay, so they lie on the same line. Okay, so nice. Someone that said E, so why you had E for the first, why E? Rhett? The distance between the heads of vector E and vector A is the shortest. Okay, all right, very nice. How about, and then V? Well, you had V for, some had V for the first, some had V for the second. How about V? Yes?
Something around
Okay, it's the one that's heading in the direction closest to A is heading, right? So yeah, it's the closest angle to A. Very nice, okay? So there's 4 vectors here that all have valid arguments on which one would be the most similar to A. These are the dot products with A. So talk to your neighbor about what you notice about those dot products and what we've talked about, and maybe what you thought was most similar and not. Okay, so let's come back together. Here's a few things that I heard. So your intuition maybe about what was most similar with A didn't match up with the numbers. Some of you, like a lot of you didn't think R is most similar, and yet it has the same dot product as A with itself. Okay, so some of you are saying like, well, I guess R is really similar then because it has a dot product. No, don't necessarily think that. What we might need to think is we need to think about really how we are interpreting a dot product and how we might need to change it or adapt it to fit our needs. What about A and C? Dot product is 0. Yeah, I see people doing this. They're perpendicular or orthogonal. Okay, that's what a dot product of 0 means. They're unrelated. In some ways, that might be like the most dissimilar. Kind of depending on how you interpret it, it'd be like T or C. Okay, you can see the negative values of O and T. If they face somewhat in the opposite direction, you'd get a negative value. Okay. Any other thoughts about this? About these values? Caleb? Or sorry, Caden?
I just realized that for negatives, that's kind of what the homework was about. Like it was asking about the positives and that. It makes more sense to it's negative, it's substitute. If it's positive, it's acute, and then it's zero.
Okay. Yeah, very nice. So he's talking about the connection with the homework about how big the angles are. If it's acute, it's positive. If it's 90 degrees, it's a 0. And if it's more than 90 degrees, so an obtuse angle, you get negative. Okay. Philip?
Yeah, I'm just trying to wrap my head around how the length of A is the same as the dot product of A and R. Like,
Well, it's not the length. We'd still have to take the square root. We'd still have to take the square root of 32 to get the length. Yeah, so. It does not. So, yeah, so if you take a vector, like if we take our vector A and we divide it by the length of A, then this is a unit vector. So a unit vector in the direction of A. Oops.
Okay.
Yeah.
Then maybe I thought that a vector dot with itself would be 1.
That's if they're unit vectors, that's true. So,
Oh, yeah.
yeah, so, okay. All right. Back to the slides. So, so all of the things that we decide, of the 4 vectors that you could argue were kind of the closest, all or most similar to A, you define similarity in 4 different ways, and then you get these 4 different vectors, but they all connect to the dot product somehow. So if you're saying the one on that lies on the same line is, well, then the dot product is, oh, I made a mistake. It's not 1 or -1. You have to take the unit vectors in those directions and then take the dot product. Then you get 1 or -1. I need to update that. If you say the two vectors are most similar if they have the smallest angle, then we can use this one here, this equation that we learned in the book and in the peanut butter book, then start solving for theta, okay, to see what the angles are. And this would be the vector v. How about the head of the 2 vectors are the closest? So you're looking at the length of the heads. You can use the dot product of the difference of those, the square root of the dot product of the difference of those vectors. And, or the projection. If you take that r, if you project it on, you get, the projection is A, so, or the projected vector is closest to A. You use dot products for those too. So, okay. Dot products are pretty easy to interpret. So one of the things we've learned through all this is dot products aren't like super easy to interpret. They are if both vectors in the dot product have a length of 1, then the dot product of those 2 vectors is just the cosine of the angle between those. And it's also the length of the projection of one onto the other. The length and the cosine is the same. So, because you're basically working in a unit circle because the radius is 1. So you can see this in this equation here. If the length of u and v are 1, then the length is 1, v is 1, so u dot v would just be the cosine of the angle between those. But once you start, if they're not 1, if the lengths are not 1 of u and v, starts to be harder to understand exactly what it is, because you can start changing, you can change the dot product just by changing the length of one of your vectors. So often we end up dividing by lengths when we deal with the dot products to get the things that we want. Okay. So when scale isn't important or the vectors are of similar length, then comparing angles is a good idea. And it's even better, instead of comparing angles, is to compare the cosine of the angles, because cosine has this really nice scale. It goes from 1 to a -1. 1 means you're perfectly aligned. -1 means you're perfectly opposite. 0 means you're perpendicular or unrelated. So, and this is a popular thing to do when you're trying to match things up. It's called the cosine ranking or cosine similarity method. And we're going to use that right now to see who in this class might be a good partner with a random student that I had to take the same survey you guys did. Okay. So let's go to. Okay, so these are the people that had filled it out by the time I pulled it off the internet. So let me make this a little bit bigger. Okay, so some of you are here. And I had another student that was not in this class fill it out, and this is that student's scores. So what did I do? I started to do the dot product here. So this is the student scores dotted with this first score. This one, those two. So I multiplied all those pairs and added them up, and this is the dot product. So right now, maybe this student or this student, they get kind of high scores. With the cosine method, we haven't done anything with the lengths yet, but still, this might be a good rule of thumb. Quick way to see who would match up well. But but I went ahead and did the length. So to do the length, I dotted each other with itself. So quickly, so like A dot A, that is like all the components of A dot 1 squared plus A2 squared plus A3 squared, right? And that's a lot, looks a lot like the Pythagorean theorem, right? To find length, you have to take the square root of both sides. So I did this in a bunch of cells, okay? So, or I basically squared each of these terms here, squared them. And, oh, sorry, I squared these. So if I square these, I get 1, 1, 4, 0, 4, 1, 1, etc. And that's what I got here, 1, 1, 4. And then I added all those up, took the square root. And so this is the length of the vectors. And this is the length of the student's vector that we're comparing it to. And I divided the dot product by those two lengths to get the cosine of the angle. So now, who's the best match here? These two, I think they were the same ones with the pretty high. Yeah, so there's 15. There was the 15 and 11. So who are those people? Let's do a little sorting here. Okay. So Caden and Annika, they came out the closest with their profile to this random student that I had fill it out. Okay. So Benjamin and Rhett, they're heading the other direction, but so not so, maybe not so good, but okay. Questions with this? Could you do this if I asked you to? Okay, because it's on your homework assignment. But I'll send out a video on how to do this. And I might even do a lot of the work for you. But you do have an assignment to actually get in and see who you match up well with. You do not have to contact the person, but if you want and say, hey, let's sit next to each other. We might have some similar interests. So if you want to just contact the closest person of your same gender, I would certainly, that would seem to be reasonable. Or the closest person of the opposite gender, but I'm not, not forcing anything here. So that's one of the assignments on the written assignment for this, but I will send out more information on how to do that. If you haven't filled out the survey, please get on and fill out the survey. It was emailed out. So, okay. This cosine ranking, it is the basis for dating sites. If you fill out a profile. It's also the basis for recommendations. Think of like Netflix. They know how you rated shows, and they will find other people who match up well, have a high cosine ranking with the shows they've rated, and then they'll see what other shows they have rated highly. Those are the ones that they recommend to you. Okay, it's cosine ranking-ish. Okay, they do some other fancier stuff, but it's kind of the basis for those. If you knew how to do that well, you could have won $1 million about 10 years ago. So Netflix offered $1 million to improve their record, to improve their algorithm by 10%. And the first person that did it, first group that did it, got $1 million. So yeah. Okay. So projections are really good at answering best approximations and also a different kind of prediction problems. Most of the projections, so far we've only learned about projecting from a vector onto another vector, or a vector onto a line spanned by another vector. Most of the projections, most of the applications projections you project onto a plane or a hyperplane, and that's actually all regression is. Least squares regression. It actually is just a progression, a projection onto a plane. We'll get to talk about that later. Can you guys think of something else that you guys have used to compare quantities that has this perfect match at 1, 0 is unrelated, -1 is an opposite match sort of scale? There's other things I know a lot of you have bumped into already that compare quantities that way, that compare variables that way. It's in a statistics class. Yes? Okay, so the R score of a regression. Yep, there's another word for that. Correlation. Yeah, so the R represents the correlation. This correlation has the same value. Is there a connection between our cosine ranking and correlation? There is. You just have to think differently. One just thinks differently about the data. They take the same data, well, almost the same data, and you think differently about it. So here's student A and student B scores. You can think about that as 9 pairs of points. Okay, so 9 two-dimensional vectors or 9 two-dimensional points. There's the graph. You can kind of see, those of you that have statistics, you can see kind of a negative relationship there. So you'd expect a negative value. Well, so we can think about this as 9 pairs in 2 dimensions. You can also think about it as 2 vectors in 9 dimensions. Okay, it's really hard to draw these in 9 dimensions. But the angle between those 2 vectors in the cosine of the angle in those 2 vectors in 9 dimensions, which we find just by using the dot product, math is still the same. That is the correlation. As long as the sum of all the values of those is 0. So if they're not, start off, you have to subtract the mean to get 2 different vectors, and then the correlation is the angle, the cosine of the angle between those 2 things. So and so you can see, yeah, if they're highly correlated, they're going to be pointing in basically the same direction. If they're not correlated, they're going to be 90-ish degrees. Okay, that's all I have time for today. Have a great day. Homework's over here on this. Homework due next time is right over here. Okay. If you haven't finished 1.1 or 1.2 online, the online assignment, it's the due date's on WebAssign for those is actually next Wednesday. We've had people joining class late, and I know some of you haven't been able to get caught up, so we just pushed them back. So have a great day. See you in a week. Yeah.
I just joined and I can't.